Hello everyone, welcome to Z&Z Classroom. I'm Mary and in this video, we're going to be learning about domain, range, and behavior. So to start off with, let's start with the definition. First of all, what does domain mean? It means a set of input values X. So when you think about domain, think about input values, think about X, right? And for range, it's a set of output values f of x. So think about range, think about output values, think about f of x, think about y, okay? So these two definitions might seem familiar, but what does end behavior mean? So end behavior means what happens to the f of x values as as the x values either increase or decrease without bound. So without bound here basically just means to the infinity. Okay, so these three would be the definition. And then I'm gonna give you guys 4 examples in this video, and that will help you to find the domain, range, and end behavior. That will help you to know how to find them. Okay. So to start with, let's start with linear functions. Okay. So for linear functions, let me draw a line here. Okay. Well, so first of all, what would be the domain of this? The domain of this, you can think about this way. Okay. So this arrow right here goes to the left forever, right? It goes forever, actually, it goes to the left. It just, since it has, it also goes down, so it goes like that. But it does goes to the left forever. And right here, this arrow, it goes to the right forever. So left and right basically is your domain, and up and down is your range. So in this case, my domain would just be negative infinity to positive infinity. And what would be my range? My range, as I said, it's up and down. So it goes down forever, goes up forever. So my range would also be negative infinity, positive infinity. Okay. And then how can I write my end behavior? So this will be my format of end behavior. As x approaches negative infinity, f of x approaches what? And as x approaches positive infinity, f of x approaches what? So in this case, let's see what use blank. So let's see. So as my x values goes to the negative infinity, which goes to the left, my f of x goes down, which is also negative infinity. So right here, I will also write negative infinity. And as my x approaches positive infinity, which my arrow goes to the right, my f of x goes up, so it's positive infinity. Okay, so that would just be my end behavior. Okay, let's go to example 2. So example 2 is a little bit different. I will draw an open circle here, and I'll connect a line to here. Here's my closed circle. Okay, so what would be my domain here? Right now, here there isn't any like arrows. So my domain is right here. So let's just connect, like, look, if I, sorry, this is wrong. So let's see, if I have a thing right here and a thing right here, I can like just draw a dashed line here for you to better see this. My domain here is just this part. Okay, it's this part. And it exclude my negative 2, since we introduced before in the inequality video or sign notation video, whatever. It's open circle means exclude closed circle means include. So my domain will be -2, 2. Okay. And my range here, let's just still draw like this. That's just for you to better see this. So my range here is this part. Okay. So when I write it, it's also -2 to 2. Okay. And what will be my end behavior? So remember this, when you're trying to find your end behavior, you're trying to find arrows in your graph, but since this graph has no arrows, the end behavior would just be none. There isn't any end behaviors. All right, so let's go to example 3. In example 3, I'm gonna do something familiar but not linear, which is quadratic. So let's see, how can I draw this nicely? I hope I did. Okay, so that will be my graph. Well, so in this graph, what will be my domain here? There are 2 arrows and it goes to, this part goes to the left forever and this part goes to the right forever. So my domain will be -infinity to +infinity. And my range here is not -infinity to +infinity anymore because the arrow always goes up. Okay, it goes up. And here is a point which is 0, 0. This 0 right here defines my limit to my range. So since this will also be a closed circle here, there isn't circle showing, since like there is an open circle showing, so it's always closed. So it would just be 0, +infinity. Okay, so it's from 0 to my +infinity. Okay, so next, my end behavior here will be my end behavior. As x approaches -infinity, f of x approaches what? And as x approaches +infinity, f of x approaches what? So in this case, when my x goes to the left, this left arrow here, my y goes up, so to +infinity, and my x approaches to the right, my y still goes up, so it's also +infinity. So that will be my end behavior. Okay. And let me give you the last example to conclude this lesson. So what I'm gonna draw is just a random graph that maybe just a polynomial graph or something. I'm just creating it. So I guess I'll just go like this. I don't know what I'm just creating a random graph here. Okay, just a random graph. So what will be my domain here? My domain, still looking at the arrows, right? Here's my arrows. Here's my arrows. I'm going, this arrow goes to the left forever. This arrow goes to the right forever. So my domain would be -infinity to +infinity. Okay. And this arrow also goes up forever. This arrow goes down forever. So my range is also -infinity to +infinity. Okay. And my end behavior here, as x approaches -infinity, f of x approaches what? And as x approaches +infinity, f of x approaches what? So when I see x goes to the left forever, my y goes up forever. So as x approaches -infinity, f of x will approaches will approach +infinity. And here, when my x goes to the right forever, my f of x goes down forever. So as x approaches +infinity, my f of x will approach -infinity forever. Okay, so that will conclude, this graph will conclude my lesson. And Thank you so much for watching it. And if you have any questions, just comment below and I will try to answer as soon as possible. Thank you.